Hello everyone, welcome to CS for All. Today we are going to talk about a very important topic, that is the standard template library functions in C++. So without wasting any further time, let's get started.
Audio Jungle.
Hi again. So today we are going to talk about C++ standard template libraries. So this standard template library helps us with so many algorithms such as searching, sorting. So we call them as functions here, and then we can also build containers like stack, queue, array, vectors, unordered maps, and so on. So these containers are built using template classes, which indirectly means that we can store any data type or objects into it. So this framework, that is a standard template library framework, is similar to collections in Java. So if you're from a Java background, you can completely relate to it. So now I will give you a quick recap of containers. So container is basically an object that stores a collection of other objects. Now the objects can be a data type. So I can say a container can be an array which has several integer data types in it. Okay, so it can be an integer 1, then a 2, then a 3, and then a 4. So it is a container. An array is a container. So it can contain integer data type, float data type, long data type, and so on. But at the same time, an array, that is a container, can also contain objects in it. Now what do I mean by object? An object can be a cat, a dog, or something else which itself has some attributes. So if I say we have a dog here, and then a dog here, and then a dog here, and so on. So we have 5 dogs in the array, and all these dogs are objects, and each of these dogs has attributes like size, weight, breed, color, and all these things. So a container can contain a data type as well as an object. Now, a container manages the storage space for its elements and provides member functions to access them, mostly through iterators. Now, this iterator is a very good concept which everyone should know. So, suppose you have this array here, so you can generally use an index to access the elements of the array, right? So the index here would be 0, here it would be 1, here it would be 2. But if you know, if the container is somewhat complex, so suppose you are using a tree which has different nodes in it, right? So you cannot access the nodes with the help of an index. You need an iterator for that. You need an iterator to access every node in the tree. Or maybe if you have a linked list, so you have this chain of linked list, so you cannot access the nodes of the linked list with the help of an index. You need an iterator again to go through each node and access the nodes, right? So this is why you need to understand the concept of iterators. So iterators are basically objects in the form of pointers. So some of the examples of containers, as I said before, is stack, then queue, then array, then vectors, unordered maps, and so on. So now let's talk about different types of containers in STL. So the containers in STL are divided into 4 different categories. So the first category is the sequence containers. So in sequence containers, we store the data in sequence, that is linearly. So for example, in array, the data are stored in the form of a sequence, one next to each other, right? So in array, the size is fixed, while in case of vectors, it is a dynamic array. Again, it is stored in linear fashion, but we can anytime increase the size of a vector. So it's called a dynamic array, right? And then we have the doubly ended queue, that is the Deque. So it is also a linear container, but it is somewhat different from array and vector. So we can expand the container from both the sides, and we can again contract the container from both the sides. So what do I mean by that? I mean, we can add elements to both sides of the deck, that is start of the deck as well as end of the deck. We can also delete elements from both sides of the deck, that is from the start of the deck as well as from the end of the deck. So it's called a doubly ended queue. So in containers, basically you will be doing three different operations. First is the insertion. So I am writing an insertion here, and then we have the searching operation, that is we will be searching throughout the entire container, right? And then we have the deletion operation, that is we will be deleting elements from the container. So in case of deck, we saw that we can add elements from both the ends of the deck and we can delete elements from both the ends of the deck. And for all these containers, all these three options, that is insertion, searching and deleting, will be of different time complexities. And then we have something called the forward list or the singly linked list. So in forward list or singly linked list, the elements are stored in a linear fashion, but the memory is not continuous. And finally we have the list, that is the doubly ended linked list, right? So we can expand that doubly ended linked list or list in both directions, so that is from the start and also from the end. Okay, now let's talk about the second type of containers, that is the associative containers. So first thing we can see here is set. Now what is a set? So suppose if you have elements like 1 2 3 4 5 and then lots of 5, let's say triple or 4 5s. Okay, now you want to store it in a set. So what will happen? The repetitive elements, what are the repetitive elements here? The repetitive elements are 5, right? We can see there are 4 5s in this series, right? So all the repetitive elements will be discarded and only one of them will remain. So what do I mean by that? This 5, this 5 and this 5 will be eliminated and only this 5 will remain. So set stores unique elements. While in case of a multi-set, all these 5s will be stored as it is. It will not be eliminated. So we will have 1, 2, 3, 4, 5, 5, 5, 5 in case of a multi-set, but 1, 2, 3, 4, 5 in case of a set. So that is how you know the difference between those two. Now let's talk about map. So what is a map? So suppose you went to a restaurant and you buy something. So let's say you buy a pizza. So let's say pizza at a cost of 500. You buy a drink, let's say at a cost of, of 100. Okay, so you buy a pizza and you buy a drink and all the costs are associated with it. So this thing, this pizza and this drink, these are the keys, and this 500 and this 100, these are the values. So map stores all these pairs in the form of a BST. Okay, and the keys will always have unique values here. But in case of a multi-map, I can have one key pizza and it can have two values, that is 500. It can also have a value of 800. So this is the work of a multi-map, that is you have keys with multiple values. So what do we learn about associative containers? Associative containers are in the form of a BST and they are always ordered. While in case of unordered associative containers, there is only one difference, that is these are not ordered, that is these are not sorted. And now finally we have the containers adapters. So we can see here a stack. So you might have heard of what a stack is. So basically a stack is a container where you push the elements one by one and you also pop the elements one by one. So suppose this is the topmost element you have. So this is the last entered element into the stack. That is the first element which was pushed into the stack is this. Then the second element pushed was this. Then the third, and this one is the last. But in case of popping it, this last element which was pushed the very last time into the stack will be the first element to get popped out. So this is the functioning of stack, and in stack you can only access the topmost element. You cannot access the middle element or this bottom element. Okay, so this is the functionality and interface of stack. Now we will be talking about queues. Now we will be talking about queue here. So queue is somewhat different from stack. So let's say we have a queue here, and these are the elements which were pushed into the queue. So this was the first element, this is the second, this is the third, and this is the last element. Now, unlike stack, when we are popping out, the first element which entered into the queue will get popped at the very first. So this will get popped first, then this will get popped, that is the second element which entered the queue. The third element which entered the queue will get popped, and then the last element which entered the queue will get popped at the very end. So this is how a queue is different from a stack. Now we will be talking about a priority queue. So priority queue is basically a heap data structure. So suppose you have some stream of elements getting into your priority queue. So let's say you have here in the stream 1, 2, then 3, then 4, and so on. Okay, now as they will enter into the priority queue, so you have here 4, then comes this 3, then comes this 2 here, and finally the 1 here. So what we can do now is we can either get the maximum element out of the priority queue, that is 4, or we can get the minimum element out of the priority queue, that is 1. So a priority queue enables these three functions, that is we can insert a new data, we can get the maximum out of the priority queue, and we can get the minimum out of the priority queue. So all these operations are in log of n time complexity. So I hope you got an overview of the different types of containers we have in the standard template library. Now we will start talking about arrays. So there are two different types of arrays. First one is the classical arrays, and second one is the STL arrays. So STL arrays was basically introduced by C++11. Okay, and we will now see how is the STL arrays different from the classical arrays. So let's start with the classical arrays. So I will include the header files, then using namespace std, then int main, and then we have to write free open input.txt as read, and then a standard input, right, stdn. Okay, and then we have the free open, it would be the output.txt, and we have to write here, and this will be standard out, right. Now let's say we have an array int arr, and we initialize this array to 1 comma 2 comma 3 comma 4 comma 5. Okay, now we want to print the elements of the array. So let's say I equals to 0, I less than 5, I plus plus. Okay, and then we will be printing the array elements. So that would be array at I, and then a space, right, and finally a next line, right. So let's see if we can build the code. So we can see we have built the code, and the elements of the array are printed here, that is 1 comma 2 comma 3 comma 4 comma 5. So this is the usage of a classical array, right. So we are done with printing the elements of the array. Now let's write up some functions. Let's say we want to update any one element of the array. So let's say void, and then update. Let's say give some parameters. So first will be the int array, and then int, let's say some index value. So let's name it I, and let's say our updated value, right, which we want to update in that actual index. So what we will have to do is I will be doing array at I equals to updated val, right. And now if I am printing this for loop and printing all the elements of the array, let's say I pass something as this, let's say update array, and then index, let's say at the first index, and then let's say a value of 50. So now let's try printing the array elements. Okay, so there was a typo. So let's try building this. Okay, say you can see 1, then at the first index there is the updated value, that is 50. So here we can see 50, and then the rest of the array, that is 3, 4 and 5. So what I am doing here is this, this array, this is not the actual array, it is a copy of the base address of this array which we made here. So suppose we have a array, so let's say at address of 2000 I have a element 1, then at the address 2004 I have the element 2. So I am actually writing up this original array. So at the address 2008 I have the element 3, then at the address 2012 I have the element 4. Then at the address 2016, I have the element 5, right? So this is the actual array which I had, which is of integer data type. So integer data type takes 4 bytes. So it jumps by a size of 4 every time. So the address jumps by a size of 4 every time, and all the elements are stored in this fashion. So what does this update function do? It takes in the base address of the original array. So what is the base address of the original array? The base address is 2000. So it takes up the address 2000, it takes up the index, and it takes up the updated value. So I is a integer data type, right? So every time it will be following up by a space of 4 in the address. So I have given a value of 1. So integer data type is size of 4. So 1 value into size of 4 would give me a 4 space jump, right? So while updating in the update function, the compiler will go from the base address to a jump of size 4, that is 2004. It will reach to 2004, and whatever is the value at that address, it will be replaced by the updated value, which is 50. So that is the thing which is occurring here. So it will get 50, and then when we are printing this, we get the elements 1, 50, 3, 4 and 5. So this is what it is happening over here. Now I want to show you something here. So let's say I want to know the size of this particular array. Okay, so what I can do, I can simply write cout and then size of the array in main function, and then what I can write is, let's give a space here, then what I can write is size of the array, right? So let's try building this. So what is the size of the array? The size of the array is 20, because we have 5 elements. Each element is a integer data type, and every integer data type has a size of 4. So 5 into 4 gives me a size of 20. So it is the size of the array in the main function. Now if I try to do the same thing outside of main, so let's say void size of array updated. Okay, and let's pass the array, and then let's not do anything, just I will be printing the size of the array. So let's say size of the array outside main, then a space, and then size of array. Okay, let's build this now. Declared here warning. Okay, so if I do this as a pointer here, okay, so I need to call this function. Okay, so let's say I am calling this function size of array updated. I called this function. Let's now try to build the code. Too few arguments. Okay, I have to pass the array. Okay, let's try to build the code now. Okay, so see, size of the array outside main is 4. So now what is the difference here? So my question is like, why did I get a size of 20 inside the main function but a size of 4 outside the main function for the same array? So the thing is, when I am passing the array outside the main function, it is not becoming a copy of the actual array. Actually, it is storing the base address of the array in a pointer variable. So this pointer array is a pointer variable, and actually this line is outputting the size of a pointer, which will vary from system to system. So if you have a 32-bit architecture, the size of the pointer will be 4. If you have a 64-bit architecture, the size of the pointer will be 8. So that is the main difference. This array is not the actual array but the base address of the actual array, which is stored in a pointer. Hence this is the difference. So whenever we are trying to print an array outside the main function, we have to explicitly pass its size as an argument to the function. If we don't do that, we cannot get the actual size of the array inside the function by using this line and the size of array. So we need to pass a size of the array explicitly as an argument into the function. Now let's talk about the STL array and see how the STL array is different from the classical array which we use. So for that we have to include the header file array here. And how is the declaration work? How does a declaration work? So let's see that. So you just have to write array here, and then you have to give the data type of the elements which you want to store. It can be a int data type, a float, or any other thing. It can even be an object which you call a dog, and then the dog has several attributes. See, it can go anyway. And then after giving the data type, you have to give the size of the array. So let's say I have a size of 5, right? And then we can initialize the elements. So let's say 1 comma 2 comma 3 comma 4 comma 5, right? Again, we can take inputs from the user as well. I'm just initiating it. So now let's try to print this. So for that we can just write simply for int I equals to 0, I less than n. So instead of explicitly declaring the size of the array, we can just use, okay, let's give the array a name. So let's say it's ARR. So we can just write ARR dot size, and then we can do a I plus plus, and we can similarly print it like ARR at I, and then a space, and finally a endl. So it should print the elements of the array. So let's now try building the code. Okay, so you see 1, 2, 3, 4, 5. So the array gets printed. So we have the array dot size, which helps us to, get the size of the array without explicitly declaring it. So now if I want to, if I want to update any of the elements inside the array, what I can do is, let's say array at 1 is, let's say 30, right? So now let's try building the code. So you can see the element at the first index got updated automatically to 30. So this is how you use a STL array. So now instead of updating the array here, let's try making a function update. So let's say update array, and we will be passing on this entire array. So let's write here this, and then a index, let's say ind, and then a update value. Okay, and what we will do is arr at index equals to update value, right? Now let's try. Now let's, okay, first of all, I will be commenting this, and I will be calling the update array. Okay, update array function. So now let's try building the code. Okay, I have to pass on the arguments like parameters, so ARR, and then let's say at index of 1 I have to pass a value of 30. So let's try building the code now. So you can see that the last time when I did update it inside the main function, it got updated to 1, then 30, then 3, 4, 5. But this time I passed the values, right, to this function, but it did not get updated. it stays as 1 2 3 4 5. So what is happening here? So this thing, it is actually making a copy of the actual array, and both the address, that is this ARR's address and this ARR's address are different, so they are not pointing to the same object. So whenever we are updating a value in this particular array, it is not getting updated in the original array. So in order to update the original array, we have to pass this array as a reference. So let's now try to build the code. So you can see this time it worked. So at the first index, we get an updated value of 30. So why is this working? This time we have passed the array as a reference. So this array is pointing to the same address as this particular array has. So whenever I am updating a value at some particular index in this particular array, all the values are getting updated in the original array. So this is how we actually pass the objects in case of STL. So now let's say we want to print the STL array. So how can we do that? So let's say print STL array, and then we pass the same thing, right? And then we don't have to explicitly pass the size of the array as a parameter. So let's say we are not using the reference this time, and let's print the array. Okay, so let's say int I equals to 0, I less than, as we said, array dot size, and then I plus plus, and then if we print it, so let's say cout array at I, and then a space, and then a cout and L, right? And now what we can do is let's just comment this lines. Let's just comment this lines, right? Let's just comment this lines, and we can call the print STL array function, right? And we have to just pass the array. So let's build the code now. So we can see that it is 1, 30, 3, 4, 5. That is, this function is getting executed correctly. So since this array is a copy of the actual array object inside the main function. So if I change anything here, if I change, suppose let's say array at 0 is 40. I change these element, that is 1 to 40. Now let's build the code. You can see that it is 40, 30, 3, 4, 5. That is, we had passed the array as a copy, and everything is getting updated inside this array. Okay, not inside this array. So now if we pass this as a reference instead of just a copy by value, any change in this array will be reflected in the actual array as well. So in order to not make any changes, we can write a const here. So whenever I am updating this here, this will result in a warning. Let's see there, it resulted in a warning because this is a constant array and we cannot update the array inside this function. So this is pretty important. So now let's try to sort this particular array. So I will be changing some of the elements of the array such that it is not sorted. So I will change 1 to 10. So let's say this is 2, then this is 30, then this is 4, and this is 50, right? Now let me tell you something. How does iterators in STL array works? So let's say we have our address 2000 as we have seen in previous parts of the video. Then we have 2004. Then we have 2008. Then we have 2012. Then we have 2016, right? And all these elements, you see, all these elements are present in each of these addresses. So let's say we have 10 here in the address 2000. Then we have 2 here. Then we have 30 here. Then we have 4 here, and then we have 12 here. So the function, that is array.begin, will be an iterator pointing to this very base address, that is the address where the array is starting, and the array.end will point to the address which is the address just after this entire array has finished. Okay, so this is 2016, right? So the next address would be 2020, right? So the array.end will be pointing to this address because the array already got finished by 2016. So if I do a sort array.begin comma array.end, so what does this line of code means? It means sort the array starting from the beginning iterator, that is the 2000 address, and sort it till the array end, that is the 2020 address. That is sort the array from the 2000 address up to 2020 address, that is all these elements 10 to 12 will get sorted. So for this sort to work properly, we need to include another header file called algorithm. Okay, so let's delete this or comment this out and try building the code. So let's see what happens. So you see the array elements get sorted. So 2, 4, 10, 30 and 50. So this is how the sorting function works in STL arrays. So this is how you sort a STL array, but in case of a classical array, it would have been sort, then the beginning address of the array, that would have been array plus 0, or you can write simply as array, that is a base address, and then you have to write array plus the address after the ending of the array, so that would be array plus n. So if you write this particular code, your classical array will get sorted. So now let's talk about another method. So if we want to fill an entire array with a particular value, we can use this thing. So let's write an array. Let's give it an integer data type, and let's say there are 10 elements in it, and let's say its name is filled array, right? And then what we can do is filled array dot fill with let's say 2. Okay, so what do I mean by this? So I have this array called filled array which has a size of 10 and it contains integer data types. Now what does this line mean? This line means that fill my entire filled array with a value of 2. And how many elements can I have in the filled array? I can have 10 elements. So there will be 10 2's in the filled array. So let's try building the code. Okay, so I have to change this as well, filled array, and this will be filled array. So let's now try building the code. So you can see there are 10 2's inside the filled array and all of them gets printed. Now we will be talking about the for each loop. So instead of writing this, we can write for, let's say int, let's say num, and then we have a colon and then a filled array. And what we can do is I can simply print num and then a space, and I can do a endl. So let's try building the code here. So you can see the same thing is getting printed. Now what am I doing? This num, what we were doing previously was we were going to every index of the array, right? But in this case, num is storing every value of the array. So we are iterating by the values instead of the index this time. So first num is going to be 2, then it is getting printed, then num is going to be 2, it is getting printed, num is again going to be 2, then printed, 2, then printed. So it is going on continuously until we reach the very end of the array. So this is how a for each loop works in C++ STL. So we have already seen how to access elements in the array, right? So we can either write array at I to access the ith index, right? We can also write array at I. So this will also help to access the element at the ith index. We can also write array dot front to access the element at the very beginning of the array, and we can also write array dot back to access the element which is present at the very end of the array. So it is an alternative, that is array.front is an alternative of array at 0, and array.back is an alternative of array at n minus 1, where n is the size of the array. Now we will be talking about STL vectors and how they are different from the STL arrays. So talking about vector, what is a vector? Vector is a dynamic array. That is, its size is not fixed. It can reallocate the memory, double its current size during the runtime. So suppose if we have a vector containing 5 elements, okay, a vector containing 5 elements, let's say 1 2 then 3 then 4 and then a 5, and now you want to increase or insert an element into the vector. So what will happen, this particular vector will double up its size, so it will become a size of 10. Okay, it will become a size of 10, and every element, so this element will get back here, this element will come here, this will come here, this will come here 4, and this will come here 5. And now if you wanted to insert an element, let's say it was 6, it gets filled here. Then if you wanted to insert another element, it's 7, it gets filled here. Then 8, it gets filled here. 9, it gets filled here. 10, it gets filled here. Again, if you want to insert one more element, the vector will again double its size. It will become a size of 20, and then it will start inserting element. So this doubling up the current size and memory reallocation happens during the runtime. So there are several methods which are associated with the STL vectors. So suppose we have pushback function, and then we also have popback function. So what does this do? The pushback function inserts an element into the vector. The popback function removes element from the very end of the vector. We also have a reserve method which helps you to initialize the size of the vector initially. That is, you can make the size of the vector fixed from the very first, and if you want to insert an element after the size is overloaded, the size of the vector will actually get doubled as we have seen before, and it will store the new element. Then we have the clear method. What does a clear method do? It does not reduce the capacity. So if we have 10 elements and capacity of 10 in the vector, the clear method won't reduce the capacity of vector. That is, the capacity of vector will stay 10, but every element from the vector will be erased. That is, the capacity will stay 10, but the size of the vector will be 0. So now let's look at a quick demo of how to use the STL vectors. So for that we have to include the header file vector. And how can we declare a vector? Let's see that. So for declaring a vector, we need to write vector and then this doubly ended arrows, and we have to declare the data type. So it can be int, float or anything, and let's write the name of the vector as vec. So it's how you declare a vector. You can use a second method as well. You can just initialize the elements of the vector. Let's say vec equals, you have 1 comma 2 comma 3 comma 4 comma 5, right? There is a third method as well. So suppose if you have an array, okay, if you have an array, let's say you have the array of 10 comma 20 comma 30 comma 40 comma 50, and now you want to copy every element of the array into your vector. So what you can do, vector, let's say int, then you have written vec equals array to array plus, let's say 5, right? So you are copying everything from the starting of the array to the ending of the array into your vector vec, right? You can also make a new vector from an original vector by using a copy constructor. We can do it using vector int, let's say second, and within brackets it will be the first vector which we were using. So this can also be done, that is, we are using a copy constructor. And finally, we can also initialize a vector like this. So let's say vector end, let's give the name vec, and we can have like how many elements do we want in the vector. So let's say we want 5 elements, and what will be the elements? Let's say the elements will be 0. That is the value of all those 5 elements will be 0. So this is another way which we can use to initialize and declare a vector. So these are all the 5 methods which we can use to initialize and declare the vector. You don't need to remember all of them. You can use any of them. Now let's write some of the methods which we can use for vector. So first method is we can write vector dot size. So this will actually give me the size of the vector. Then we can write vector dot capacity. This will give me the capacity of the vector. Then we can write vector dot max underscore size. This will actually help me to know what is the available RAM for the vector. Then we can, as we said, we can do a pushback function which will actually help me, if I pass on any value, this 20 will be added at the very end of the vector, that is after 5. If we do a vec dot popback, so what it will do is it will delete or eliminate the very last element from the vector. So if I had a 20 after this 5, that 20 will be eliminated from the vector on doing a popback, right? Now, if I want to erase any element from the vector, how can I do that? So we can do that by using vec.erase, and then we have to pass the iterator, that is the index of the element which we want to delete. So let's say vec.begin plus 3, right? So what does this mean? This means the 4th element will be deleted because we count the index in the format of zeros, right? So 0, 1, 2, 3, that is the 4th element will be erased. So now let's say we want to erase a range of elements from the vector. So how can we do that? We can do that by using vec.erase. Let's see, vec.begin and then a vec.begin plus, let's say we want to erase 4 elements, so we will write a 4 here. So this will actually erase first 4 elements from the vector. Now as we did a sorting for the STL arrays, we can similarly do a sorting for the vectors. So how can we do that? We can just write sort vec.begin and a vec.end. So this will actually help me sort the all elements of the vector. So this is very similar to the STL arrays. So now we will be talking about Deque. So what is a Deque? As we have talked earlier about Deque. So Deque is basically a container at which we can both insert and delete element from both the ends of it. So we can insert an element from the front, which we called push front. We can insert an element from the back, which we call push back. We can delete an element from the front, which we called pop front, and we can delete an element from the back, which we called pop back. So these are all the functions, the major functions which a Deque uses. And one more thing about Deque is all the elements are not stored in contiguous forms. That is, they may be stored, they might not be stored, but they act as a linear container. So now let's see how to implement a Deque. So for that we need to include a header file called Deque. And now let's see how to initialize and declare a Deque. So first we can do Deque. Let's say we have to give some integer type. So we have given this, let's name it first. So this declares a Deque which is called first, right? Again we can do Deque int second. What we can do is we can use a fill constructor. So suppose we want 4 values and each value is like 100. So this will create a Deque which has 4 values in it and each value is 100. We can again create a Deque from the second Deque. So what we can do is let's name it third, and we can do second dot begin comma second dot end. So what this line will do, it will copy the entire, or it will be iterating through the second Deque, that is this Deque, and it will be copying every element from the starting to the ending of the second Deque. Now there is another way of declaring a deque. We can use a copy constructor. So we will just be passing a third deque here, and this fourth deque will contain the entire third deque. So this is how we declare and initialize deque. There is one fifth method. So we can create an array. Let's say it has 1 comma 2 comma 3 comma 4 comma 5, and we have its size as size of array by size of array at 0, right? So this n will contain the size of the array, and then what we can do is dec int, let's say fifth, and then we have array comma array plus n. So this will copy every element of the array inside it, and that how we form the fifth dec. Now let's look at some of the methods which dec uses. So first of all, we can do a dec dot push front. So we can insert any elements, let's say 6. So what this line of code will do, this will insert an element at the very front of the dec. So we have a dec here, suppose 1 2 3 4 5 is the dec. So this line of code will insert a 6 at the beginning of the dec. That is, we will have 6 comma 1 comma 2 comma 3 comma 4 comma 5, right? So this is how the push front works. And again, if we do dec dot push back, let's say 7. So what this line of code will do, this will insert a 7 at the very end of the dec. Now if we have dec dot pop front, so what this line of code will do, this will eliminate the very first element that is from the front of the dec. And if we have dec dot pop back, what this will do, this will eliminate the very end of the dec, that is the element which is present at the very end of the dec. There are two more functions by which we can see the element at the front and back of the dec. So we can write dec dot front to see the element which is present at the very front of the dec, and we can write dec dot back to see the element which is present at the very end of the dec. Now we will be talking about stack. So we have talked earlier about stack. So what is stack? Stack is basically a container, and suppose you have elements to be filled into the stack. So let's say 1 2 3 4 and then a 5. So first this 1 gets inserted here. So let's write 1. Then this 2 gets inserted here. Let's write 2. Then this 3 gets inserted here. Let's write 3. Then this 4 gets inserted here. Let's write 4. And then this 5 gets inserted here. So let's write 5. So all the elements are inserted in a sequence. Now if we want to pop the elements, that is we want to eliminate the elements, so what element will be popped first? The element which enters the stack at the very end gets popped first. That is first in last out, or last in first out. So 5 will get popped at the very first, then 4 will get popped, then 3 will get popped, then 2 will get popped, and at the very end 1 will get popped. So this is how a stack works. So let's go to Sublime Text and see a demo of this. So for using a stack, we need to include the header file stack. So let's write it. And this time we will be working with a string data type. So let's write string here. Okay. So let's first create a stack. So for that we have to write stack and then the data type. So the string data type we are going to use this time, and let's write here libraries. Okay. Let's write libraries. Now what I want to push into the libraries is a book of physics. Okay. Then what I want to push back is a book of, let's say, chemistry. Then what I want to push back is, let's say, a book of computer science. And finally I want to push back is a book of mathematics. Okay. So this is how you push elements into a stack in STL. Now I want to print every elements of the stack. So how can I do that? I will be writing while stack is not empty, that is libraries is not empty. I will be running the loop until the library is not empty. So what does this method do? This method returns a boolean value and helps me to know if the library is or if the stack is empty or not. If the stack is not empty, the loop will continue running. If the stack becomes empty, the loop will break. So what I can do is I want to print the top element of the stack, right? So libraries dot top, okay, and then I will be eliminating the top element, that is I will be popping the top element. So what I can do is libraries dot pop, and I have to use the endl here for better output. So if I try to build the code now, let's see what happens. So you see the code is printed, like it is compiling and giving me an output, and we can see the element which gets pushed at the very end is popped at the very first. That is, mathematics got pushed at the very end of the stack and it is getting popped at the very first. So last in first out, we can see the demonstration here. Now let's talk about queues. So what is a queue and how is a queue different from a stack? We have talked about it earlier, but yet again I will be discussing this. So what is a queue? Queue is a container, and suppose you have to fill elements 1, 2, 3, 4, 5. I always take the same elements, right? So first, 1 gets pushed into the queue. So we have a 1 here. Then 2 gets pushed into the queue. We have a 2 here. Then 3 gets pushed into the queue. We have a 3 here. Then 4 gets pushed into the queue. We have a 4 here. And finally 5 gets pushed into the queue. We have a 5 here. Now every element got pushed into the queue. Now in what sequence will the elements get popped out? So in case of a queue, unlike stack, the first element that gets pushed into the queue will be popped out first. So 1 got pushed at the very first and it will be popped at the very first. Then will come the turn of 2, then 3, then 4, and finally 5. So the element which got pushed at the very first got popped at the very first. The element which got pushed at the very end got popped out at the very end. So this is how a queue works. Now we will go straight to Sublime Text and see a demo. So to use queue inside my code, I need to include a header file called queue. And again, as we use a string for stack, let's again use a string for queue here. So we will have to include a string here. The string header file got included, and now we need to make a queue. So let's give a string data type and let's name it this time basket. Okay, let's name it basket this time. Now what we can do is we can push into the basket, let's say fruits. Okay, then we can push into the basket, let's say we can push drinks here. Okay, then we can push into the basket, let's say biscuits. Okay, so these are the things we are pushing into the basket. Now suppose we want to see the very top element of the basket, that is a queue. So what we can do is cout basket dot front. Okay, so let's try building the code. Okay, so you see the at the very front, that is the element which got pushed at the very first, is staying at the very top of the queue. So fruits gets printed at the very first. Now let's print all the elements and see how a queue works actually and how it is different from the stack. So again I will be doing while basket is not empty. While basket is not empty, the loop will go on running. So I will print basket dot front, and then I will be popping the top element from the basket dot pop. Okay, and I will be printing them in separate lines. Now if I try building the code, so you can see the order in which the elements got pushed into the queue is same as the order in which they get popped out, which is very different from stacks, because in stacks the order in which element got pushed into the stack was pretty much reversed as the elements which got popped out from the stack. So the order is different in case of a stack and a queue. So now we will be talking finally about the priority queue. So what is a priority queue? Again, we have discussed this earlier. So suppose you have here a basket and you want to insert elements. Suppose you have 100, you have 50, you have say 21, you have 35, right? And you have a 90. So you insert them, every one of them, into this basket. Now I say you have this elements here, right? You have this elements here 21, 35 and 50. Now when you want to print the top element, or when you want to pop an element from the priority queue, the element with the highest value will get printed or eliminated from the priority queue. So if you do the operation, first 100 will be printed and it will get eliminated. Then we have the highest as 90, so 90 will be eliminated and printed. Then we have the highest as 50, so 50 will be eliminated and printed. Then we have the highest as 35, so 35 will be eliminated and printed. And then we have a 21 at the very end, so it will also get eliminated and printed. So this is how a priority queue works. So it actually helps you to eliminate and print the maximum element which you currently have inside the basket. So an actual implementation is kind of a tree data structure. I'm not going deep into that. So let's see the use of a priority queue in the Sublime Text with a demo. So to use a priority queue, we have to include the header file queue. And how to declare a priority queue? For that, we need to write priority queue and then any data type. Let's write int this time, and we can give any name to it. Let's say chocolate, okay, or let's say candies, okay. Done. Now what we can do is we have to push the elements into candies. So let's say we can push candies dot push, let's say 100. Then we push, let's say 50, okay. Then let's say we push, let's copy this too, let's say we push 90 and then a 20, okay. And finally let's say we push one more, let's say it's 30, okay. Now if we try to print, like if we try to print the top element of the priority queue, what will it be? It should be 100 as we discussed earlier. So let's try printing it. Candies, okay, cout candies dot top and L. So let's build the code. Okay, we made a typical mistake here. Okay, so let's try building the code. Again a mistake, small mistakes. Okay, let's try building the code. So you can see the top element is 100 and it gets printed. That is the maximum element present inside the basket. Now let's try printing all the elements from the priority queue. So let's say while, okay, let's first delete this. It's pretty same as we did for queue and stack. So while candies is not empty, run the loop. While candies is not empty, run the loop. So cout candies dot top and then handle for proper printing format, and then candies dot pop. Okay, so if we try to print this, we're seeing C. So first 100 gets printed and eliminated. Then what do we have the maximum among 50, 90, 20 and 30? So 90 would be maximum. So 90 gets printed and eliminated. Then what do we have maximum among 50, 20 and 30? We have 50. So 50 gets printed and eliminated. Then among 20 and 30, what is maximum? 30 is maximum. So 30 gets printed and eliminated. And then we have only 20. So 20 gets printed and eliminated. So we see the elements get returned in descending order, that is first 100, then 90, then 50, then 30, then 20. So now if we want to return the elements in ascending order, we just have to do a slight variation here. We just have to write vector int and then a greater end. Okay, so this particular line of code will help me to return the elements in ascending order. So if I try building the code this time, I can see the elements are returned in ascending order. So this is how a priority queue works. So that marks the end of our complete STL video. I know there are something missing like hashing. So we will be covering up hashing in the next module. We discussed it a little bit in the very first of the video, but we will be covering it in the next module after the STL module gets finished. And the video was pretty long. It took a lot of efforts. So if you like the video, please consider dropping a like, subscribe to the channel and share it with your friends. And if you have any doubts or queries, you can comment down below. You can directly connect with us through LinkedIn or join our Telegram channel. We have a daily discussion over our Telegram channel, so you can join that. So see you guys in the very next video. Till then, stay happy, stay healthy. Bye.
It's my life, it's